This is Euclid Book 6, Proposition number 7, Part 1. And I'm sorry to say that this will be a two-part proof because of how long this stupid thing is. Alright, it says, if two triangles have one angle equal to one angle, the sides about the other angles proportional, and the remaining angles either both less or both not less than a right angle, the triangles will be equal angular and will have those angles equal, the sides about which are proportional. Okay, he says, let A, B, C, and D, E, F be two triangles. Well, here's A, B, C, and here's D, E, F. And these triangles will have one angle equal to one angle. The angle BAC is equal to angle EDF, EDF. The sides about the other angles ABC and DEF proportional, so that as AB is to BC, as this is to this, so as DE to EF, DE to EF. Now here I drew a 4-inch line and a 2-inch line. I drew a 2-inch line here and drew a 1-inch right there, so everything's proportional. And the first, each of the remaining angles at C and F less than a right angle. Well, the angle here at C and the angle here at F, these two are less than 90 degrees. And I wanted to make sure of this, so I went ahead and made two right angle triangles. I didn't have to do that, but I did. And then goes on to say, I say that the triangle ABC is equal angular with the triangle DEF. The angle at ABC will be equal to the angle at DEF. And the remaining angle, namely the angle at C, equal to the remaining angle, the angle at F. So what he is saying here is that this, when we get down to the proof, this triangle will be equal angular to this triangle right here. And of course, if we want to go on with this, we could say that angle ABC is equal to angle DEF, and of course angle BCA is equal to angle EFD, yada yada, and so on and so forth. For if the angle ABC is unequal to the angle DEF, one of them is greater. So if the angle here at ABC is not equal to angle DEF, then one of these two is going to be greater than the other one. So they're saying let ABC be the greater. We're gonna hypothesize that ABC is an angle greater in size than the angle at DEF. And on the straight line AB, well, here's AB. Okay. And at the point B on it, let angle ABG be constructed at angle DEF. So now we're going to say the angle ABG, this angle right here, is now equal to DEF, which is right up here. And we can do this by Euclid Book 1, Proposition number 23. Then since the angle at A is equal to the angle at D, this angle up here is equal to this angle over here. And the angle ABG is equal to the angle DEF, which we just established. Therefore, the remaining angle AGB is equal to the remaining angle DFE. Well, where's AGB? AGB is now equal to the angle DFE. DFE. And then we can go on to, we can say that that is true because of Euclid Book 1, Proposition number 32. 32. Euclid Book 1, Proposition number 32. Therefore, the triangle ABG is equal angular with triangle DEF. Okay, well, here's a triangle ABG, this triangle right here, D, E, and F, which is this triangle right here. Therefore, as AB is to BG, so as DE is to EF. As AB is to BG, so DE is to EF. And we can say this by Euclid Book 6, proposition number 4. But as DE is to EF, so by hypothesis AB is to BC. DE to EF, AB to BC. Therefore, AB has the same ratio to each of the straight lines BC and BG, which is by Euclid Book 5, proposition number 11. Therefore, BC is equal to BG. So we're saying that the proportion between AB and BG is the same as the AB and BC, that making BG equal in size to BC. So that the angle at C is also equal to the angle at BGC. So now we're saying that this angle here is equal to this angle here. No. Now we're saying that this angle here is equal to BGC, this angle up here. That would be by Euclid Book 1, proposition number 5. But by hypothesis, the angle at C is less than a right angle. Therefore, the angle BGC is also less than a right angle. Okay. So if the angle AGB adjacent to it is greater than a right angle. Okay. So AGB would then be hypothesized as greater than a right angle. And it was proved to be equal to the angle F. So AGB was proved to be equal to the angle at F, right over here. And we're saying all this because of Euclid Book 1, proposition number 13. Therefore, the angle at F is also greater than a right angle, but it is by hypothesis less than a right angle, which is absurd. Therefore, so in other words, they're saying that since we're now saying that DFE is greater than a right angle, we had said originally that DFE is less than a right angle, and so it can't be both less and greater. Therefore, the angle ABC is not unequal to the angle DEF. Therefore, the angle at ABC is not unequal to DEF. These two angles are now equal. Therefore, it is equal to it. But the angle at A is also equal to the angle at D. This angle right here is equal to this angle right here. And the remaining angle at C is equal to the remaining angle at F. And this is by Euclid Book 1, proposition number 32. Therefore, the triangle ABC, which is this one right here, is equal angular with the triangle DEF, which is right here. And that finishes the first part of the proof. I will tell you more in a future video, so stay tuned.